It depends on something, for example, like this. How much time will it take you to solve the problem? Okay. Directly. Like directly means like you don't look at the answers, you just work it out, and then you find your answer there. And this just takes a lot of time if you don't know how to directly solve it. Okay. The other possibility here, these are kind of negative, but that's where they're using the answers. Let's just, you're like, all right, I'm going to use the answers every time. That's my strategy. I feel good about it. Well, it can take too much time if you don't do it right, or you don't learn anything when you submit when you try the answers. So if you're going to try the answers, you better do it correctly, and you better learn something which is wrong. Learn something each time so you get the right answer. So really your decision, like what you decide to do, comes down to which is faster or more familiar to you. Meaning, like if you think you can directly solve it, you should directly solve it. If you feel like, okay, I'm going to be faster trying the answers, then you should do that. It's totally up to you. And that's the challenge here. And so the more practice you do, the more you'll be able to make a decision. Now, this strategy only applies to multiple choice questions, right? Obviously, if it's a free response question, which you will see, those are the ones where you got to fill in the answers. If it's free response, well, you have to direct solve because there are no answers to try. Does that make sense?
Yeah.
Okay. Any questions or thoughts or feedback from that?
I don't think so. I think
Okay.
I'm good on that.
All right. So let's talk about what you might see when you're looking at the multiple choice. So there's a couple of different types of multiple choice patterns that you should be on the lookout for. So the first pattern is ascending order.
Okay.
So ascending order would be like this: 3, 4, 5, and 6. Okay. You might see descending order. It doesn't have to be by one. It could be like, let me go ahead and it could be like 12, 10, 8, and 6. Okay.
Got it.
There's then what I call patterned answers. So patterned answers are, and these come in a couple of different flavors. The most common one, it would be like 3, 30, 300, 3,000, something like that. Or 10, 10, 20,000, so on. The pattern answers can also take the form of sort of like powers. So it could be like 3, 9, 27, 81, something like that.
Right.
And then the most frustrating are what I call the engineered answers. Okay. And this is, you don't see this as much on standardized test, but let's just say, for example, the correct answer is -3. +3 will also be in there because there's a sign issue, right? Like what if you get the wrong sign? Or let's just say an intermediate answer is 7. They might throw in -7. Okay. And you tend to see this with fractions as well. So and these are like why you have to be very careful with when you try the answers or working out directly, because sometimes the common mistakes are this. Like, let's say again, the answer is -1/2. You might see 1/2 in there, or you might see 2 because it's the reciprocal 1/2, or -2. And these are answers where you can get a lot of frustration because you just they just don't come out the way you want. It's not like, so sometimes you see tests where there's only like one reasonable answer. It's not always like that. So that's the challenge of like deciding, okay, am I going to use the answers or am I going to just work it out? All right. So when we look at this first example, maybe we've looked at this before, I have no idea if we have or not. What is the positive solution to the given equation? So when you look at the answers here, and then you need to look at the answer 2, 4, 6, 8, you've got to decide like which is faster. Is it faster to try the answers or to direct solve? And so this is where, like, if you haven't done math in a while and it's the summer, you're probably going to lean towards trying the answers. If you're just done absolute value equations in your algebra class or algebra 2 class, you might say, oh yeah, let me just solve it. So what do you see here? How do you see this problem?
Well, absolute value makes the -4 a positive 4.
Okay.
So 2x plus 4 equals 8.
So just to be clear here, like your triangle is like 2 times 2 minus 4 absolute value. Does that equal 8? Like that's what you're trying to figure out here.
No.
It does not. So A is out, right? But let's just say you did A wrong. Like you didn't, I don't know, you somehow thought it was 8 or something, 8 minus 4. It still isn't right, but you have to do it correctly, right? So that's the issue. You got to make sure whatever you're trying, actually you do correctly. All right, so why don't you keep trying the answers there until you find the one that works, please.
Six.
2 times 6 minus 4 equals 8. That's 12 minus 4, which does equal 8. Good. Yeah, so the answer is 8, right? Or I'm sorry, the answer is 6. So I almost, made one of those classic mistakes where it's 8 and I checked 8. Like you gotta, even if you get the right answer, you gotta make sure you actually circle the right one on there. So nice job, right? You got the correct answer. Trying them is slow though, right? Because if the answer is D, you got to try A and then B and then C. So you might consider trying them in this direction, because if you're going to try the answers, not always, but maybe more times than not, the answer is going to be at the end. So it's better to try the last one. Maybe. Like none of these are absolutes. Like I think we talked about the, baseball, you get the scouting report in the pitch, like, yeah, he throws a fastball on the first pitch every time, and you show up and he's throwing a curveball on the first pitch or a changeup or something. Or, go to a scouting report on a team, they always play man to man, and then it's 2-3 zone, and you're like, what are we doing? Good. So nothing works perfectly. Nothing is an absolute, always works. Now, one of the things you should notice here is that you only had to substitute in one time. Okay. If you had to substitute in 2 times, that may change how you decide to do this. And here we've got an example problem like this, where you need to substitute in for X on the left and X on the right. Okay. So if you're gonna try the answers here, which is okay, you have to substitute them in both places. When you substitute more than once, there's more opportunities for error. You could also just try solving it, meaning, distribute the 5 in, get things on one side, move some stuff around. Totally up to you. How do you see it when you're looking at this?
I like just plugging it in.
All right. So, like I suggested last time, maybe you start from the bottom up. I can't guarantee that's going to work. I can only just say that if you were to do that in general, it would save you time, but not always for every problem, but for all the problems it would. So go ahead and try these and let me know which one you think it is.
All right. -4.
-4, let's try it here. So it's 5 times -4 minus 3 equals 10 times -4 plus 5, right? So that's 5 times -7, which is -35, equals -40 plus 5, which is -35, right? Good. So you got the correct answer, but right, like everything I just said was wrong, right? It was the first answer.
Yeah.
And
So it's
and that's what,
always,
right. So there's no absolutes, right? There's no, at least in this situation. I mean, they're just strategies, they're just like, okay, maybe I'll try this, maybe I'll try this. The more you're aware of them, the more you have a chance. And it's kind of my thought for you. So when you decide what you're going to substitute in the numbers, so far the numbers have been nice. Okay. One place, two places, that's okay. Three places, maybe that's not so good. It all depends. Now, when you look at the answers here, and I think we've looked at this problem before, but in another context, it's like two of the answers are fractions, two of the answers are whole numbers. Okay, so if you're going to try the answers, you probably are not going to try the fractions. But the game or the guess here is, well, which is more likely to work. Now, if you try the answers and it's kind of like saying, okay, he's fastball first pitch guy, so let's wait for it tee up, try those, right? The fractions are not ideal. You probably have to direct solve it to do that. So um that's kind of my guidance here for you. Um like you to decide if you want to try the answers or direct solve it, and then see if you can come up with the right answers. I would encourage you to try, C and D first.
is this 8/3?
So you're saying you tried that, or you tried to solve and you got that? Tell me what you did.
Well, I tried out all the other options and I'm not, and eight
Okay,
over three, I'm,
let's try 4. I mean, 4 is kind of that you hear this like term like low hanging fruit. Like it's like, yeah, you reach up and you grab it.
okay,
That's what
yeah,
they.
we can try
Let's
four.
just try it. 2 times 4 minus 4, does that equal 4? Right, you got to put it in for the x on the left and the x on the right. 4 minus 4 is
0,
2 times 0 is
0,
0 equal to 4?
no.
Okay, so let's try the next one. 8 minus 4. 2 times 8 minus 4. What does that become?
8 minus
Sorry,
4 is
sorry.
4,
Okay, and 2 times 4 is
8,
this right?
yeah.
Okay, so that goes to the point of like, if you're gonna try the answers and you try them wrong, like you're gonna get really frustrated because like 8 was correct, B was correct here, but if you didn't you didn't see that it worked, then you're on to trying fractions, you're direct solving this, and
Yeah.
that's kind of a nightmare. Okay. So, unfortunately, like I've probably given you the perspective, or not perspective, maybe I said, hey, you just always try the answers. And like that's a strategy sometimes students think will work. It doesn't work. Here's an example where these are all fractions. Okay. You would not try these. I mean, look how complicated this equation is. 5k plus 2 minus 7 over 6, 13 minus 4 minus k over 9. Right? You would never, 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 never try them. You never try these answers in there. Okay. So this one you have to direct solve. Okay. And this is a pretty sophisticated problem here. I mean, there's no way to sort of like guess what the answer could be. So, just like everything, it's all like never 100%. You don't know for sure. If you were to direct solve this, you'd want to multiply both sides by the LCM.
These common multiple.
Yeah, of 6 and 9, which ends up being 18.
Okay.
Okay, and maybe I'll just work this one out just to have you see it here. Let me snip it in and grab the equation only. All right. By the way, do you know when you start school? Do you have that date kind of dialed in for?
August 7th.
Yeah. It's too soon. So it's right there around the corner. Okay. So to solve this, you would multiply both sides by 18. Okay, now what a lot of students don't realize, and this does save you time, is you actually divide before multiplying.
Divide before multiply.
Yeah, so you take 18 and divide it by 6, for example. 18 divided by 6 is 3 times this 5 times k plus 2 minus 7. And then same thing over here on the right, 18 divided by 9 is 2. It's 13 minus 4 minus k all times 2. And the reason you do this is when you divide before multiplying, the numbers get smaller, more manageable. Because you multiply by 18, 18 times 5 is 90, 18 times 7 is whatever it is, 112, 18 times 13, I don't remember. You get big numbers. So if you can remember this, that's kind of really saves you some time here. So in terms of like what you do next, another kind of confusing thing here for students is that this is really one term that I'm circling. That's 5 times k plus 2. It's really one term. Terms are separated by the plus and minus operator. So there's this term here and then this term here.
Right. So, I'm sorry, I missed your.
Well, let me highlight it because it's a small point. It's we're gonna do this problem. I'm not gonna do a bunch of these, but that's a term and that's a term. Then I'm highlighting 13 is a term, and then 4 minus k is a term. It's a little awkward. So 3 times the 15 and then 3 times the 7. So it's 15 times k plus 2 minus 21 equals 2 times the 13. That's 26. And then this 2, there's really a 1 in front, so it goes with that. So it's minus 2 times 4 minus k, like that. So we get 15k plus 30 minus 21 equals 26. The negative 2 gets to distribute in, so minus 8 plus 2k, like that. All right, and so now we combine like terms. So this 30 minus 21 is 9, 15k plus 9 equals 26 minus 8 is 18 plus 2k, like that. So now 15k, we'll get those a little closer together. 15k plus 9 equals 18 plus 2k. So we're going to subtract 2k from both sides. So you have 13k plus 9 equals 18. Subtract 9, subtract 9. 13k equals 9, divide by 13, divide by 13. So k ends equaling 9 over 13. All right, so if you go back to the answers, that it is there. It's there, it's letter B. Now, I don't know how long that took me to solve, and I'm obviously explaining some things as I solve it, but you should really keep in mind there are questions where you may not want to do the work. you may just want to guess and move on, because that's a lot of work. And what if you get all the way down here and your answer isn't right, isn't in there? Then you wish you had spent the time guessing.
Yeah,
So it's not a first strategy to guess, but it is kind of a like, well, am I even going to be able to do this? You know,
yeah. So it's always
so
an option.
it's always an option. Yeah. I mean, it's like, you don't think you can get a hit off the pitch, or you just lean in and take a, take a fastball or something. Off the forearm guard. I don't know, but there's kind of, there's something you can, you'll map out some strategies. Okay.
Right.
So again, here's a new problem here, brand new problem. All the answers are fractions. So it's like, would you try them? Would you direct solve? If you substitute them in, you only got to put them in one place. That's good. But which one do you try first? Um,
I'm gonna
like,
try. Wait.
why don't you decide what you want to do here and work it out, and then
Okay. Wait, is W
these are
W
the
gets
values of
replaced
W.
for something, right?
All of these would go in for W.
Okay, got it. I'm having a hard time getting just a clear answer on this one too. I don't know.
So are you trying the answers, or are you trying to solve it, direct solve it?
I'm trying the answers.
Okay, and that's fine.
Uh-huh.
That's a fair thing here. So let me give me a moment here to get this snipped in the way I want. All right. Okay, so which answer did you try first? A, B, C, or D?
A.
Okay, so 3/5 times 9/20, like this. Okay. Now the mistake is to do this, is to go, okay, it's 27/100. The reason that's a mistake is you want to try to reduce if you can. Okay, meaning like does 3 go into 5, or does 9 go into 20, or 3 go into 20, or 9 go into 5? And the answer to all those is no. So this, this is not the right answer. Okay.
Right.
So now let's try B. 3/5 times 4/5. So no, does 3 go into 5? Does 4 go into 5? Does 3 go into 5? No. So this says 12/25. Is also not the answer. So now let's try C. 3/5 times 5/4. Now finally we have some cancellations here. Does 5, see how 5 goes into the 5 on the bottom there?
Yeah.
Okay. See those cancel? So this becomes 3/4, like that. Sorry, that's not the right answer. We want 4/3. So this one is also wrong.
So yeah, it's all right.
Okay, so the answer must be D. It's D because none of the other ones. Okay, that assumes that you've done it correctly, like you've correctly put all these in. The answer is D. So let's talk about why. So 20/9. See how 20 goes into 5 4 times,
Yeah.
and 3 goes into 9 3 times. 1 times 4 is 4. 1 times 3 is 3.
Yep.
That was your correct answer.
Dang. I see.
Okay. Now, the other way to solve a problem like this, we should talk a little bit about direct solving. I'll give you a few worksheet problems here to try. Is when you're, sorry, I guess this has got all this other junk around it. Okay. You undo multiplication with division, but when it's a fraction, you can also multiply both sides by the reciprocal. So on the left, see how the 3's cancel and the 5's canceled, and you're just left with W.
Yeah.
On the right, you get 20/9. See how that's the correct answer?
Yeah.
Perfect. Okay.
Mhm.
So let me give you a couple here to try. I would recommend trying this direct solve method.
Okay.
So let's say it's 2/3 x equals 5/7. Okay. Go ahead and solve that the way we just did in that previous example, please.
Wait, is there a set of numbers or no?
No, you have to just go ahead to here. You can't, we're working on direct solve.
Okay.
So what did I do to direct solve the previous one? Why
You
did I
flip
multiply
it.
by this number?
You flip it.
Yes. So I'm asking you to do the same thing here.
What if they're like it's not multiplying smoothly?
Well, just like in the last problem, sometimes it's a fraction. Just it's something. So like you're multiplying both sides by 3/2, hopefully.
Yeah.
Okay. So on what does that become on the right? Over here, what's 3 times 5?
We got 15 over 14.
Right, and that's your answer, and that's okay. That's what it is. Okay,
Got it.
you have to be comfortable with answers that maybe aren't pretty.
Mhm.
Let's try another one. How about 3/4 K equals 5/9.
20 over 27.
20/27. Good. You multiply by 4/3. 20/27. Now there are problems where there will be something that reduces, but we're not gonna focus on those for today. So let's look at another couple of questions here. Now here's a new problem. It says, what is the positive solution to the given equation? So your choice here is to substitute the answers. Okay. Notice you'd be substituting them just one place. All right. But two of the answers are kind of large. It's something to consider. Like, do you know what 41 squared is? And assume you don't have a calculator for the moment. Do you
No.
know what 51 squared is?
No.
Probably not. So that's where you gotta like try to think about what can I actually do? What can I actually do here with with uh with this? I love sports analogies, like if a pitcher's throwing really fast, you choke up and you bat and you try to hit it, just get it in play.
Mhm.
That makes more sense than swinging for the fences and the odd chance you're gonna make contact correctly. Like, do the most reasonable thing here, which if you're gonna try answers, you would try 9 and 10.
Yeah.
If you were to solve this, you would have to move some things around. Maybe you remember from your algebra 1 class, but it's more involved than just trying to answer, especially when you only got to put it in one place. So I've kind of said enough here. If you want to give this a try, let me know what you come up with.
It'd be 9.
It is 9. Good. All right. So the next example here, next problem we'll look at, kind of related to the last one. When you're trying to solve this, you could put these numbers into the equation. You got to put it in twice. But on the right here, you have a square root. And so the square roots, you have to remember, like, what can you actually take the square root of? You can take the square root of 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, and so on. Okay. Which means that, like, you want to think of, it's not just like try the answers. It's like try the one that actually you can take the square root of. Now, like, I know you can take the square root of 1, but remember you're putting 1 in for x, so it becomes 1 plus 10. And you don't know the square root of 11. I don't know the square root of 11. Okay. It has to be one that works. You follow what I'm saying? Or is that
Yeah.
okay? So the point is,
So
you know,
sorry, you go. You go.
pick a value of x, pick one of these here that you can actually take the square root of when you add it to 10.
2.
2 plus 10 is 12. What, you don't know the square root of 12.
Oh, you're right. Oh, okay. Then maybe like oh. Are you hinting or are you trying to say like put in 0?
Well, 0 plus 10 is 10. Do you know the square root of 10? I'm trying to get you to think about what you can actually do. Meaning, like, what do you actually know the square root of? And I'm sort of hinting at it over here in this list. Like, Yeah, zero, take the square root of zero, but it's not zero, it's 0 plus 10. So if x were negative 10, you would get back to 0. If x were negative 9, you would get back to 1. If x were negative 6, you would get back to 4.
I mean, you can't take the square root of 14
That's right. So that answers out.
and 19.
How did you come up with 19? You're still using these numbers over here on the left. All right, let me give you a different example. Let's say it's the square root of x
Oh,
plus 5.
then it's 16.
Okay, like if x is 1, this is the square root of 6. If x is 2, this is the square root of 7. If x is 3, it's the square root of 8. If x is 4, well, finally, we've got one we can take the square root of. That's what I'm trying to get you to see. Like, none of these other ones are good because you can't take the square root of them. But 4 is good. So go back to your problem here. It's the same idea. Like, yes, these are the numbers, but you're not taking the square root of these numbers. You're taking the square root of these numbers after you add 10 to it.
D.
So that again, like, does that work on both of them or just the right?
Well, 6 minus 2 is 4, and
Good.
16 squared is 4.
The square root of 16 is 4. Yes. Good. Okay. I didn't mean to overwhelm you with that, but I would just, again, just try to think through. You don't just randomly choose. You really do want to have a plan. All right. So this one, you can try the answers. You got to try them in 3 places. 1, 2, 3 places. That's up to you if you want to try them. Solving this, you could solve a little more work, but could be done. What do you think here? You're going to try the answers, or you're going to try solving it?
I'm going to try to solve it.
Okay, I'm going to just step away for a minute, but I'll be right back to check with you.
Okay.
How are you doing on this one?
I'm almost done, I think.
So let me jump in with a little hint here. Sometimes the best thing is a combination of both. If you go to a Mexican restaurant, they always have those combination platters. I don't know why they have them. Other places don't. At least that's what I remember when I used to go out to eat a bunch. Uh, so, for example, if you subtract 2x squared from both sides, which is totally legitimate, you get 4x equals 3 plus x squared, like that.
Mhm.
Now, when you try the answers, you're not trying them in 3 places, you're trying them in 2 places.
So it looks a little bit easier.
Yeah, so like most things in life, you never want to be too extreme in one direction or the other. You want to say, okay, I'm gonna do, I'm gonna try the answers, maybe I'm gonna try something first. You don't put all your eggs in one basket. Lots of cliches to consider. But yeah, why don't you maybe if you ran into some problems, maybe try this as well. Try it after doing this and
C.
so 4 times 3, does that equal 3 plus 3 squared? 12, does it equal 3 plus 9? That's good. All right, so hopefully kind of getting the hang of this. Let's try at least one more here. I mean, what do you think about this strategy compared to some of the other things we've talked about?
Yeah, it's not that bad. I like it.
Yeah, and they really all work together. It's not like, oh, there's the strategy A, B, C, D. They're all sort of overlapping, interweave with one another, but hopefully it gives you some idea of how to proceed, especially when you don't know how to do a problem. That's the kind of the key. When you're like, I don't know what to do, then it's where you're like, well, let me see if there's a strategy I can use to help.
B.
Okay, you're good. Let's see if there's any more here. Yeah, so let me just kind of throw this one up. I'll just close out with this question, just kind of talking about it. Because we talked a little about this idea that like you can only take the square roots of certain numbers. Okay. So there's a number that when you add it to 28, you can take the square root of, and then you add it to 1, you can also take the square root of. Okay. So like 1, if let's just say x is 1, this becomes the square root of 29 and the square root of 2. Do we know those values?
No.
No. Now, this is where you got to sort of say, okay, what's the next square root that I do know? Well, the next square root you do know is the square root of 4. And that works for x equals 3, but that becomes the square root of 31. Do you know that one?
I also don't know that one.
You know, I don't know it either. So that's like, all right, what's the next one? Well, square root of 9. Okay. Well, that's x equals 8. 8 plus 1 is 9. 8 plus 28 is the square root of 36. Do you know that one?
Yeah, 6, right?
You do. And so do I. And that's good. That's like, oh, okay, we can do this now. So that's that when you're looking for square roots specifically, and this may be the most valuable thing we talked about today, you will be able to do it if you look for the ones that you can actually take the square root of. So all right, go ahead and stop here.